All right, welcome everybody to another Wednesday Product Spotlight. And today we are traveling to Honduras to meet with Gilbert Meyer, MMC-3, which is doing affordable, panelized, modular, flat pack construction. And they are shipping all over the world. This is going to be an amazing conversation, so stay tuned. We are going to be packed with videos, and we're going to have some show and tell on the products that's being used. And guess what? Gilbert comes from the ballistic world, where they used to test panels for triple threats. So there's a lot of engineering behind what's going on here. So join us. We're going to have Gilbert come on in 1 second. But right now at Dave Cooper Live, we are bringing you the people and the processes that are building it better. Our guests and topic include experts in building systems to building science, building codes, and the tech used to build it better. We are always seeking out the best and the brightest in the construction industry and discovering all of the ways that innovative buildings come to life. And I have to tell you, we cannot do this without our sponsors. So I want to say thank you to Forward Solutions Group, Ben Hershey, Joe Butler, two of the best in the industry. And I mean that with all my heart. They are a team with more than 175 years of experience developing and specifying manufacturing for panelized, volumetric, modular industries with best practices in development and implementation. They offer consulting with investors, developers, manufacturers, builders in using off-site manufacturing methods. Forward Solutions Group is driving companies to succeed where others have failed. For more information, please reach out to Ben at forwardsolutionsgroup.com, and we will put that in the ticker as well. Also, thank you to Howick. Howick is a pioneer in the technology of precision light steel roll forming machines. For over 40 years, their commitment to innovation in cold form steel, also known as light gauge steel, precision manufacturing, uncompromising quality, and exemplary customer service have defined the Howick way. Their commitment underpins the competitive advantage enjoyed by their customers. To learn more, visit their website at howickltd.com. All right. Thanks again to our sponsors. These shows are not made possible without them. Time to get to Honduras. Gilbert's waiting, and I know all of you out there are waiting to hear more from Gilbert. Gilbert Meyer, welcome to the show.
Thank you for having me here.
Yeah, no, thank you for taking the time out of your busy day. I know you're in the process of, manufacturing and building this new system that's out there, and we're super excited to talk about it. But Gilbert, first, as we ask everybody on this show, we want to know everything about you from the moment you were born to this very moment in time. Do not leave out any of the good stuff, or we will call your mother. And if your mother's not there, we're going to call somebody. We'll call your sisters, your daughters, your brothers. We want it all, but you only have 2 minutes to do it.
Okay. I will leave some of the stuff out. I had a pretty wild youth. I was born in Switzerland, in Lucerne, and I graduated in Switzerland as an engineer in mechanical and electrical. I wanted to learn English, so I started to work for a Swiss company which made EDM machines, electric discharge machines, which are controlled by computers. It's actually was a pioneering company. And so I went to the United States and I wanted to learn English. And after a year, I wanted to go back to Switzerland. So during this visit in the United States, I met Miss Honduras and she became my wife. So that's my connection to Honduras. So that's how I learned first time about Honduras. I went all by myself to Honduras to the wedding. I did not know the language, and now I speak pretty good Spanish, but I did not know the language. So I told her that when I have to say yes, she has to kick me because I had no idea what they were asking me. So then the magic word came and she kicked me and I said yes. So that's how the Honduran thing started. I learned a lot about machine tools. When you know machine tools, you know how things are manufactured, what is needed to make a new product, because the machines we sold were made to build machine tools. I give an example. We pioneered, at that time, the integrated circuit was developed, and you have these little metal legs coming out of the black plastic, and this is called a lead frame. And we're using a carbide die, and carbide dies, they're made out of small little pieces. And then we introduced the wire EDMing. We pioneered with a company called Arnold Engineering, with a German super tool and die maker. We developed a die all out of one carbide piece, and we put it into a 60-ton Ruder press. And all the owners of the company started to walk away because they thought that thing is going to blow up. And that was the start. That's when they started to do like, thousands of pieces per second, and today, what happened with the lead frame industry. All these chips became more complicated and are being used everywhere. I also, was involved in other interesting development with our specialized machines, like going to nuclear submarine engines in Westinghouse. And then I started getting into sales. I always had my engineering hat on, so I tried to develop and improve our machines. I started then my own dealership, and I continued selling machines. I traveled to Japan. I started also to sell Mitsubishi machine tool machining centers. Machining center is basically a mill turning, controlled by CNC, computer controlled machining. And then I decided to go to Honduras. And I was involved in helping foreign companies to set up manufacturing plants in Honduras. So, in Honduras, we have the textile industry. Honduras is big in automotive, especially wire harnesses. And now what we want to do is we want to try to, we decided to build this housing in Honduras. I have twin girls, which are young from a second marriage. And I went back to the United States because I wanted them to go to school in the US. So a friend of mine told me that there's this defense company, they have this triple thread wall, if I can help sell it, because they haven't sold a lot. They had like an embassy in Iraq.
Right.
And so I was introduced to the CEO there, and I studied their product, and I told them that your product is outdated, it's too heavy, too expensive, and too thick. So I told them that, I know enough about materials, so I can develop a new wall. So I started to read the patents of existing defensive walls, and I saw that they're very expensive. So they use very advanced materials which cost expensive. They don't care how much money they spend to save lives, which, I understand. But what I try to do is find regular building materials and re-engineer them to become stronger. And by using different materials on different layers, we got actually to 95% close to the strength of the expensive materials. And in the ballistic industry, if the bullet goes through and you're 5% less strong, you just have to increase the thickness by 5%. But now the end result, you have a triple thread panel, which is 10 times cheaper than the expensive ones. Our wall was only 2 inches thick, and the UL8 test is a test where you shoot M16. The bullets travel at 1,500 feet per second, and it's a square of 4.5 inches. There's a shot on every corner, and the golden shot in the middle, and you cannot have not a single piece of shrapnel can go on the other side. And we passed all the tests. We also passed the test against blast. We do that at Intertech in a shock tube. It's actually pretty expensive. It's $6,500 for every second of explosion. But they have high-speed camera and test sensors to show the wall, and we pass those tests too. And then they have the forced entry test, where for 30 minutes, there's one supervisor who's an engineer who knows you have to send them the drawings. So they know everything. They know all the weaknesses. So they have sledgehammers, axe, they have crowbars. You know, there's 3 people, and they're pretty big guys. So there's 4 guys are trying to break through that wall, and one guy gives them instructions. And the goal for them to fail me was that they had to make a hole of a diameter of 12 inches. And we passed that test too. So we were approved as a triple threat wall. And then I gave seminars in the Washington area, the defense industry, and they all said, "Oh, I love your wall, I love your panel, but you know, how do you connect it to the floor? How do you make a corner? How to attach a roof? Because it's like a chain, you know, it will break where the weakest link is." So then I started to think of a modular defensive structure, and I developed a structure which again has the same defense characteristics like wall panel. And but then I was thinking, you know, I was looking at the world out there, and I said, you know, there's a much bigger problem in the world, and that is affordable housing. So I felt that I developed a system. When you take away some of the ballistic materials, we still have all the glass technology in it. So our cheap low-cost houses are actually past the U.S. glass standard of 8 psi.
Okay.
So I started to. I left. I was on a consulting agreement with that company. So I told them that, you know, I want to go my own. I want to do the low-cost housing, and so I started to develop that, and I was looking for money, and I had a big problem finding money. I used up all my money. I didn't have anything left. The problem was, the money I needed was too little. My statements of the low cost and the speed of assembly, nobody believed it. So basically, it's like I come to you, Dave, and say, "Dave, I have this idea of a car. Give me $100,000, and we can make that car and sell it for $3,000." You would right away think I'm a crook, that I steal your money. That was my problem. But then I was lucky. I used LinkedIn a lot. LinkedIn, by the way, is a very good platform to
I agree.
Connect and find solutions. So I had one gentleman, he answered me and he said, "I have a son who is crazy for low-cost housing." And he made his internship at Icon. There's the people who built the 3D printed houses.
Yep.
So I was in Philadelphia at that time, so he flew to Philadelphia. I met him. I showed it to him. We right away got along good. You know, he just graduated from Harvard as a mechanical engineer, and he started to see right away this has big potential to become very big.
Yeah.
So his father started to fund us, and we started to with the development of our prototypes.
Sure.
The problem we had is when we started developing the prototypes, we ordered. Let me tell you a bit. In my time with setting up factories, I also become very good at global sourcing, and I sourced material all over the world. I give you one example. the defense company, sorry for getting back to the beginning, but that's important. The defense company was using a US, I don't want to mention companies, a US product which cost $30 a kilo. And it was pretty good. But what we did is we ordered, I did a research all over the world. We ordered 20 glues to find out who is the strongest. And what we did is we did a tier test to see, which breaks the first. And we found 2 Chinese glues, which were only $3 a kilo, 10 times cheaper, and they were about 3 times stronger. The other advantage is the other one smelled really bad. You had to use a lot of ventilation. It didn't smell at all. And what we did is our triple threat wall. Normally, people, when you have a ballistic wall, you shoot bullets. Usually, you have the impact layer. Impact layer's purpose is to break the bullets in pieces. You still have all the energy; it keeps going. So then you have to slow down and have another catch layer to catch the last debris. So most of the people, the first layer is the impact wall. What we did is we used a piece of ACP, aluminum composite panel. I'm going to get later to it. I'm going to show you some samples because we used that on our homes, and we glued the impact layer, which was granite on our first wall, on the back side. And if you shoot a bullet at granite or any stone or tile, it breaks up in many pieces. This glue was so strong that when you put your granite on the backside of the ACP of the aluminum composite panel, it didn't have any cracks. It just made a hole with a comb towards the outside. So that was basically our final test, and we decided to use the Chinese material. One thing I found out that a lot of, and that's something for the American companies to learn about. A lot of companies, a lot of foreign companies are willing to work with you, are listening to your ideas to modify, to improve the product. And we found much less resistance in getting help from that. And they gave us, a lot of those manufacturers gave us the help for free. We didn't pay for it. So it eventually improved their product too.
Right. So, okay, all right. So you're taking all this experience that you have from the ballistic world, the triple threat world, all of that engineering that you put in place to save people's lives in combat or bad areas. Let's talk about, how what you're building now, right? You took the low cost and the speed, you shared your why, how you got there. Let's talk about exactly what you're building now. Let's get into, here is our system. And for those of you that are out there, we do have a video that we're going to share. Gilbert is going to show you the parts and pieces. He has the product with him there to give you the parts and pieces to this. And Gilbert, we are live on LinkedIn, YouTube, Facebook, and Twitch. And we go to Twitch because that's where the young folks are. So please hit that like and share button right now. So Gilbert, let's get into the actual product that you're building. And let's start talking about, this low cost, this high speed product. There's no crane needed. Unskilled labor is all you need. I said unskilled. You can flat pack it, if that's the terminology we're going to use, anywhere in the world. It's low cost, hurricane resistant, and up to into a Cat 5 hurricane. And with the windows and doors closed, it's waterproof up to 1 meter. I don't know where to begin with this other than let's start talking about the product.
Okay. First of all, a lot of people who see that video, I had some replies to saying, it's a nice product for office wall separation, things like that. Our product is actually stronger than what's existing right now in the building industry. Most of the panelized systems, they just use the panels and they're stacking the panels to each other. We have in between every panel, we have a vertical structure. So basically, maybe Dave, you can show a picture which shows like without the panels. It's like an ad. It's like a building going up.
Yeah.
Can you show that?
Yeah, we can pull that up. Why don't we do this? Why don't we run through the video real quick, give everybody an idea, and then we can get into the pictures. Does that work?
Okay, great. That's good.
Let's do that. And if you want to walk people through what's going on, okay, Gilbert, as they're lowering it.
The horizontal lower elements, they are aluminum profiles. You're basically placing them the way where your walls go. You're in concrete. You have a concrete foundation, and you use first with a small drill. You make your holes, and then use the big hammer drill to make the holes for your anchors. And then we have every 200 millimeters. We have a hole, so you have an 8-millimeter bolt connecting your vertical element to the ground. Then you see this black little box. I talked to that about later. Just a shock absorber. These are FRP structural vertical elements. The wall panels, when we ship to the clients, the windows will be installed, the doors will be installed. So all you have to do is slide it in. Anything which is put on top of this horizontal aluminum profile, it doesn't use any fastener. It just slides into the groove. Okay, I'll explain later how we connect everything. Mm-hmm. Now, at the end, the last corner, you have to get the verticals all the way down from the top. And now you're having the same profile in reverse on top, and you have a long bar of 10-millimeter diameter, and you're pulling the top down to the bottom, blocking everything in between. And this makes actually a much stronger construction, because when you have a rigid product, it will break much easier than when you have a flexible product.
Yeah, for sure. And
I know I got a lot of feedback of that's not the way you stand on a ladder, but in Honduras, it's we're on a very low budget, so we didn't have money at that point to buy a crane.
Yeah, for sure. If you could turn down your volume,
yeah,
Gilbert, if you could.
Yeah.
If you could turn down your volume on your end a little bit, I'm getting some feedback coming back from your computer. Just turn down the volume you're listening to a little bit. Okay, but I do have some questions with what's happening here. These two gentlemen that are putting this together, when we were talking, you said, they're unskilled labor. I mean, they just started working for you not too long ago. Is that correct?
Yeah, they had 2 weeks of experience at that point. I just hired them.
Right. Got it. And now, all of the framing, all of the tracks, all of the bushings and everything else that we're seeing here, this is already pre-cut, assembled, no dumpster needed. Accurate?
Right. And also, I'm going to get later on to, if I forget, remind me, I want to talk about the sealing, the rubber seals. So now, he's finishing up the top horizontals, and then you just use a small little hand tool to crank it together. And it actually, the shock absorber is, I'll show it later. I have a sample here. It's rubber. It's a rubber block, which gets squeezed together when it's under tension.
All right, so they're finalizing
the roof supports. The roof supports are out of fiber reinforced polymer, FRP, which is a fantastic building material. It's insulating, and it's as light as wood and almost as strong as steel. Now here we show that we don't need a crane. The roof panels are a little bit more heavy, and the way to do it is you basically just push them up and tilt them, and then you place them into the channels. In the building industry, a lot of people need to use the meters, for distance.
Right.
You don't need it with us, because we have guide rails. Everything which interlocks together is with guide rails. So all I have to do is clip it in. I'll have all the components here on my desk, and
Right.
I'll explain them to you later.
Mm-hmm. Tell us about the walls. What's the thickness, the R values? Walk us through that wall ceiling. Is it all the same?
Okay. I would I would like to actually explain the wall when I can show you the components. That's much easier when the video is done. But I can talk a little bit. The walls are, if not everybody knows what ACP is, ACP is aluminum composite profile. What we're using is, it's a composite which is 4 millimeters thick in total, has 2 aluminum skins of 0.2 millimeters, and a polyethylene core. Each material you can bend very easily, but together it's actually very, very strong material.
Mm-hmm.
The beauty of that is also you don't need to paint the house. The aluminum composite is covered with a finish called PVDF. It's guaranteed by the manufacturer for 14 years to not lose its color. And I'll show you later on the color table. You can have mirror, wood, concrete finish, any finish you want, any color. So you choose the color for the outside of the house and the color for the inside of the room, because the panel is finished. That is what makes it a lower cost, because you don't have to do siding, you don't have to paint, you don't have to do drywall. This is all stuff which requires skill and labor, and labor is expensive.
Yeah, talk to me about that last part that's around the top of the unit there. Is that a rain collecting?
That's the roof support, and then the roof panels sit on the roof support, and then you have you put in the roof panels on the roof support, and then you have the roof clamps which clamp the panel almost like a railroad profile.
Okay,
it's like a piece of steel, and it holds down the roof panels. And if you have, for example, a gust, like in an explosion or in a Cat 5 hurricane, you have a negative pressure trying to pull the roof off your house. Because the shock absorbers, and every 4.6 feet there's a shock absorber, it actually lets the 10 millimeter bar go up, so the roof can actually flex a little bit up and snaps right back. And that is the trick, that it doesn't break away. Now here you see the inside of the house. When the panels are delivered, they have a protective film on it. So you build your house first, and then you rip the protective film away. So everything is going to be nice. Our technology does not create not even an ounce of trash.
Wow. Let's see what else we got here.
Yeah, that's it.
Yeah. So love it. Let's get into the details, the cost, all that stuff. So we'll leave the cost, I think, for the end, because I think that's what's going to surprise people the most out of this. But why don't we talk about the products? Can you show us what the wall assembly is, what the R values are, and also we need to get into how much more finishing. How do you add electrical? How do you add plumbing? Any of those things?
Right. Let me first of all do the folks out there, because I saw in some of the discussions people did not understand what FRP is. Okay. Fiber reinforced polymer. You think it's good for me to explain?
Yeah, sure.
Okay. Here, this is our vertical, which is basically a T connection. So you can basically have a panel connects to each side. You have, this is the aluminum panel frame profile, and there's rubber seals on the side with like wings. So you're putting this from the side. On the bottom, it does the same thing on the vertical. You put that in here, you put it together, then you have your ACP on the outside, and you can see now you're creating a natural channel for your electric or plumbing or whatever you want to do. So the whole house has natural channels, vertical and horizontal, to to guide your
Your wiring,
utilities.
your plumbing.
Now,
Right.
what this is basically, it's almost like fiberglass. It's stronger than fiberglass. It's e-glass, and this is a vinyl resin. What we plan in the future, but we have to develop that first. We want to go with basalt fiber, which is spun from volcanic rock, which is a green material, and phenolic resin. Phenolic resin is fireproof, and basalt fibers are used to make uniforms for firefighters. So it's a good material for that. So the way you create that is, it almost looks like a textile operation. You have a lot of spools on one end of the machine with yarn, with mats, and they get guided towards the dye, and then it gets soaked into this fabric gets soaked into the liquid plastic, which has been heated up, and then it gets through guides, it gets pulled into the dye. It's about 1 meter long dye, which gets heated up, and then on the other end, the finished profile comes out. The process is called pultrusion, because unlike extrusion, where you push the material through the die like aluminum profile, you have to pull the hard part on the one end. That's why they call it pultrusion. So this is FRP.
Is there any expansion, contraction, different climate zones, any issues that from these different materials, or can they be used anywhere?
It really doesn't matter, because the way our technology works is we're using automotive technology. We don't use caulk. Caulking doesn't last. Your house always leaks air. It's expensive because somebody has to put the caulk, has to be experienced, you need skill, you need labor, and that increases the cost.
Right.
And so we use, I'll show you a rubber seal here. Here's, for example, one of the rubber seals. It's like, has two little wings, which bend. And the reason we use that, you can drive a car 100 miles an hour through rain and you don't get wet. Now you can't try that with a house, but you typically don't have rain horizontally coming at 100 miles. So we use these rubber profile seals. They're actually very cheap. This profile cost me about 25 cents a foot. You only have to pay one time for the dye. It can be as complicated as you want. Once the dye is made, you can produce miles and miles of it.
Yeah.
And there's three purposes of that. One is weather sealing for the water. The other one is tolerance adjustment, because especially when you have long profiles, nothing is perfect. There's bends, there's movements, temperature, the different materials expand at different levels, and the other one is lateral shock. So basically, it's almost like a little shock absorber from the end. So if somebody bangs on your wall, it's shock absorbing. Here is basically, this is a piece of ACP here. That's 0.2 millimeter aluminum both sides and polyethylene plastic in the middle. But you cannot bend it. It's very, very strong. So we use this material to cover the foam core. This is polyurethane foam. Polyurethane foam is one of the best insulators. Our wall thickness is 4 inches, so we have 4 inches of polyurethane foam. Here you can see little test samples glued together. Now, one of the advantages, we use what's called flexible foam. So when you hammer on our walls, they actually give. It's like a shock absorber, and that is why our walls will pass the APSI blast code in the United States. And the other nice thing we found out is, we didn't know that until we built it. We built a finished house. When you go in an empty house, you get this echo, and it doesn't happen that much. It actually absorbs your noises better. you also don't hear the noises on the outside. You know, like when I'm inside, this door's closed and we run our machines in a factory. Right. I can still have a conversation with somebody.
Love it. So let's.
Then I told you about the roof support. This is the roof support. Okay. Now you have on top of the roof the upper. This is the horizontally that sits on the floor. And then you have the wall panels in between, and then you have this. And this is an example to show how easy it is. You see these two grooves? They have to go right in between. We actually, on our next version, that we use too big of a plate because I followed the instruction from the manufacturers of the tolerances, and I made a 3mm plate. And we, on the production version, is going to go down to 2mm because they actually can produce it very accurately. And then you can see here is another groove. On this side is another groove. So your wall panel gets laid on this ledge and it gets spotted right there. So you don't need an assembly person does not need to have a measuring tape. Everything just interlocks together. Now, let me tell you the advantages of using profiles. Profiles, once you have the tooling, they can be produced with miles. So scaling is no problem.
Okay.
The problem with today's modular industry is that it's a huge investment. You need huge factories because you're building very large things. We can actually put 1,600 square foot of house into one 40-foot container. So we can pack our elements the way IKEA packs its system. Once we go in full production, we're going to use 30 feet long machining centers to drill the holes to an accuracy of 0.1 millimeters. And that's very important because it's like IKEA. You cannot ship components and then you have to re-drill them and then refile them to make it fit. You know, if we mean that you can put that small house where I'm sitting on, this actually takes about 2 hours to assemble.
Right. So speaking about IKEA, IKEA is global, ships all over the world. Let's talk about the markets. Like you're located in Honduras. Where are you actually looking to provide housing?
Wherever people buy it from.
Yeah.
And we have a lot of interest. There's a big market in Africa.
Yeah.
Once we grow, we may actually plan to do a factory in Africa.
Okay. And I mean, and then there's a huge
market. We plan somewhere in Eastern Europe, like Bulgaria, Poland, Czech Republic, somewhere like that.
Right.
Czech Republic. I have 25% of my blood is Czech.
Czech. I love it. So what about North America? Are you looking to come up into the Gulf Coast states or the Sunshine States, I think they call it?
We're going to eventually have our tech center, our R&D center is going to be in Texas. That's where we're going to hire all the engineers. Our houses will have, from the ground up, we will have smart home technology. See, one of the problems right now is everything is an add-on because we're stuck in a century-old building technology. And we went off-site, but we did not add different technology to lower the cost. So we still use a lot of labor. You know, we still use nails and screws. We don't do that. We use 8mm and 10mm bolts, which to my knowledge is much stronger than a nail.
Yeah, and you're putting it into aluminum framing, not wood. You know, a lot of times our fasteners are stronger than the wood that they're holding. So, I mean, it's true, right? We over-engineer the daylights out of the fasteners sometimes, and you know, the wood's going to break apart before the fasteners.
Right. So basically, our house is so water resistant. If you want to do spring cleaning, you can go with your hose inside the house and wash it like a car.
You can power wash the inside of the house.
We're going to use our patent also to make interlocking furniture components. And and once we have that, you can even wash the furniture with hose.
So you showed us a single family home, but this is approved. So I mean, it's approved for 10 floors, 10 stories, right?
No, nothing is approved. I mean, we still have to ship our final version to the States, which we'll do hopefully June, July. We
Okay.
have 4 units arriving in California. We have already the location where we're going to install it, and that's where we do all the testing.
Got
Hopefully,
it. You
because California is a big market for affordable housing, we can talk to the government in California, and they can help us.
And what about disaster, FEMA, things of that for providing disaster relief
also a great thing, because we're probably not much different in price than a tent.
Yeah. So let's talk about that. Let's talk about what the price point is. What are you looking at these units that, like the one you showed us in the video, retailing?
Okay. I'm about a week away from knowing it exactly. As we all know, building material prices are going up, especially wood. Luckily, my materials didn't go up the same level. My problem is I'm shipping containers. The cost of I used to pay $3,000 for a container from China, for example, to Honduras, and now I'm quoted between $8,000 and $9,000. So that's why we're planning. Actually, at 3 o'clock, I have a meeting with the largest bedding company in Central America, and we're going to discuss to make the foam here in Honduras, because the foam is shipping wise, we can cut our cost in half if we don't ship the foam. That uses the most. Even if we compress it, you can compress it 3 times its size when you transport it, the foam. But if you just import the liquid, it either comes from the US, Germany, or China, it's 5% of its volume. So the foam grows. So it's almost a no-brainer to produce the foam here.
Right.
And then we can produce exactly to the right size.
So let me can I show your website?
Yes.
Let me pull this up here real quick. Because the website actually shows. I mean, these are big, complex product. That's what you just showed us in your video that you're building. But you're really not only going after the single-family market, you're also going after the multi-family housing market.
Yeah, office building, anything. Pending physical tests from my FEA calculations, we should be able to go 10 floors. And really, our increment of layout is 4.6 feet or 1.4 meters. So you can design inside corners, outside corners. So we're not. This looks like a box. People say, it looks like a container house. But we can make an L-shaped house. We can make a U-shaped house. It doesn't matter. And the other thing is we're introducing is, you guys all know what a MEP is, mechanical, electric, plumbing.
Yeah, sure.
We're going to have, the only limitation you need to follow is the MEP has to be adjacent to any source which uses water. And like that, we can pre-make what's called a plumbing tree. We can hang it to our MEP room, MEP module, and we then with quick connects, somebody who is not a plumber can then connect the other side. Same thing with electric. We try to get the skilled labor away from the building, and we're going to do something like it's being used for years in the automobile industry, and that is called a wire harness. A wire harness, we have in Honduras many factories who do wire harnesses for Chrysler, Toyota, Hyundai. I think Honduras employs right now 7,000 people in the area of wire harnesses. And a wire harness, basically, you have a board with a lot of pins, and then the people are running your cables, put connectors, you hook it up to a computer, you test it, if it works well, and then you pack it. And then you ship it with the house, and then you just lay it into the channels, and you connect your connectors. And here we go. And we don't provide any 110-volt lighting. The house is pre-designed to have the low voltage circuit to be completely LED. We also integrate a smart home technology right into the building. Even the cheap houses, we don't make a difference. If it goes to a poor country, to a rich country, it's the same quality. We use, here you can see here, this is a programmable switch. It can become anything. So once you program it, it become a single switch, a double switch, a triple switch, a slider for curtains or for air conditioning, and it's programmable. Even the text you can program in any language. You change the color, and the beauty of that is we also going to have an app, so you can run your house also from a smartphone via internet.
Sure. Sure. I love it. I mean, I think the technology and what you have developed definitely has a strong place in the market globally, for sure, especially with the affordability of it, the ease of application, the ease of installing, the fact that you can ship it around the world. I did have a question though, and we put it in the comments also. We put a poll question, right? With your product, you say affordable modular housing or manufactured modular housing, right? One of the things we've been fighting in the States and around the globe, Gilbert, is truly what is this system? What category would it fall in? 2D, 3D? So the poll question says out there for everybody out there, because we just want to know. We're trying to resolve this. Is it a panelized construction system? Is it volumetric construction? Is it a modular building? Or is it other? Please comment. Let us know what you think it is, because where does it fall, right? Because when we think of modular, a lot of people think of modular or volumetric in our country. They're thinking of full 6-sided finished modules, whether it's bath pods or volumetric, where it's full units. So we put a poll in the comment section. Give us some good feedback on what they think and what we should talk about.
I thought you wanted to know my opinion.
Well, I do. I do. But we did put a comment out there. What is your opinion?
That's great. Actually, I'm totally new to the industry. When I started this thing, first of all, I made it a point to not study the way buildings are built, because I wanted to create something totally new. And that's what I recommend to everybody when you want to design, when you want to go totally new and make a disruptive technology, you have to jump out of the box and don't look at it. It's actually a funny story. Later on, I had to house sit a friend's house, which had a kitchen remodeling done. I think he paid $35,000 for it. I couldn't believe it. And I was a month in there, and because I can work with a computer, I can work anywhere. So I told him, no problem. And I could not believe how cumbersome a lot of things is, how cumbersome drywall installation is, or installation of a window. With our profile we selected, I can install a window in 2 minutes with no fasteners. And I looked at a video, and it takes an hour to install a window on a stick-built construction.
Right.
I rate our technology, I rate as really something new. It's almost like we're going back on site, because on-site construction, you're bringing your wood and everything to the construction site. You have your saws. You make a lot of dirt, a lot of garbage, and you're creating your pieces. We are bringing also our elements to the construction site, but they're high precision. Nothing has to be done but assemble it.
Right.
2 people can actually assemble at a speed of 200 square foot an hour. And it all can be done without cranes, because every component can be carried by 2 people.
Right. I love it. Yeah, no, for sure. And I do agree with you. I think the out of industry mindset is going to be a disruptive player in our industry. And I use that term lightly. And I do think that we do need to think differently. It's the only industry that hasn't changed in over 100 years.
Exactly.
I don't think the people that are in the industry, not all of them, are going to be able to get out of their own way of doing it, and thinking to be much different. So, last question: you're looking to ship all over the world. How do you manage building codes, building inspections all over the world? How are you looking at that? Even in the United States, California is different than Texas, and Texas is different than Florida and Pennsylvania. How are you going to manage that?
I know that. That's our biggest headache. And anyone out there who can give me a recommendation or help, I accept happily any suggestion how it can be done, because, like I told you, I'm not from the building industry.
Right.
So we're probably going to hire some people in the States who help us doing that. I think what will help is we have some connection to governments. When you put in government properties, you can you can forget about the code because they can government is powerful in the United States. They can override anything.
Yeah.
And in Honduras, the code is not as stringent. So we decided our first installations are going to be in Honduras. We have a gentleman coming in end of this month, and he wants to build in Trujillo, which is a beach city in Honduras. He wants to build a small hotel with cabins. So he's going to come and look at a prototype, and he's pretty much sure that he's going to do that. Right. We're also going to set up a sales center in Honduras to put 3 houses up, totally furnished, totally usable with water and everything, electric. And any large developer would never buy just from a catalog. They would want to see the factory. We do the same thing. I will not buy a product from a supplier without going there and look at the factory. Because you want to make sure that everything is, first of all our factories are ISO 9001 approved. We want to make sure that it's clean, it's not a dirty factory, they follow all the laws. Because if you don't follow that, it can backfire down the road.
Sure. Well, yeah. I mean, safe, clean is super important. So we have one of the questions that was in the comments as I'm looking through. No floor panels. Are you looking at floor panels? Does everything have to be on concrete?
Okay. We wanted to get feedback on the single story buildings. After that, all the designs are done for multi-floor. We actually have the same similar. It's similar to this are our floor support panels, and then what we do is the floor panel are built similar. All the floors are insulated. The floors are 6 inches thick, so you got actually a 6-inch insulated floor panel. The floor panel are just laid on top of the floor supports, and then when you build up the next floor, you're putting your horizontal, and the horizontal overlaps the floor a little bit, locking the floor in place, which means, again, we eliminated fasteners. And eliminating fasteners is eliminating labor, and the whole thing is lower cost. So everything, like when we design something, we try that everything blocks the next element, and in the end, we have a bolt securing the whole thing.
Love it. Love it. Well, Gilbert, listen, I mean, that's our hour. Can you believe it? It's been an hour.
Only?
It's already been, we're at 57 minutes already. So, Gilbert, thank you so much for coming on and sharing your story. I'm watching the views. I'm expecting this is going to get a lot of views coming up, and I think people are going to be very interested, and I'm sure we'll see some more comments and questions come up as well, just like you were seeing in the pre-show stuff.
Yeah. I have one final word.
Go ahead. What is it?
It's important. Okay. If I tell you that it is possible to produce an insulated panel in 2 minutes, you would say, it's not possible. But we are actually going to plan a transfer line where we will produce wall panels every 2 minutes. And at the cost, I told you that I'm not sure, but we're probably around $35, $36 a square foot. And that includes everything, including smart home technology.
Installed on-site minus no land. That's just the product.
Yeah. That's no approval. That's just the product.
Is that with concrete slab?
No, because the concrete slab is different in every country.
Yeah, understood.
You need your supply of utilities. You need the concrete slab. The utility has to supply to the point of our map module, and then we can go from there.
Got it.
The beauty also is that if you have a house, you can start small. If your family grows, you can buy more components, and you can add rooms. If you run out of land, you take your roof off, you buy floor panels, and you add another floor.
Got it.
And reinstall the roof on top.
Yeah.
And the other thing is that a lot of people think when they look at the video, we are very strong. We're actually 14 times stronger than stick build and 3 times stronger than masonry construction.
14 times stronger than stick build. Is that what you said?
Yes. Yes.
Wow, and 3 times stronger than masonry.
And we have done tests on that.
All in lightweight stuff. Right? You can't lift that much masonry with 2 people.
No.
or a wood structure, right? Or one of those panels. It would be next.
The trick is our technology allows any developer to lower the rent to half and at the same time double the profit. No technology exists right now who allows you to do that.
Wow, that's amazing to me. I mean, really, really. All right, well, listen, I think this is wonderful. I mean, the comments are already starting to pop in from the different platforms. I'm seeing it. Hey, Damian Penton, well, here's a question, too. Would the foundation be different based on the geographical area?
Again, I'm not a builder.
Regional, so right?
This is I'm not a foundation guy, so you would have to talk to a foundation guy. Our house is our small house weighs 3,800 kilos. So it's much lighter than a regular house.
Well, this also comes down to what kind of foundation you do in central Pennsylvania is much different than what kind of foundation you're going to do on the Gulf.
And then the other thing is, if we go, I recommend helical pier foundation. It has a low capacity of 500 tons per pier. You can actually build 10 floors on a pier. And the way it works is you drill, it's like giant screws. You drill them into the ground, you check your torque, and when the torque reaches a certain level, you reach the right depth. I mean, they're using helical piers to fix a broken foundation. Yeah,
no, they are, for sure. And a lot of the helical piers are made out of composite material as well. So
no, they're steel.
They're all steel or aluminum?
Oh, yeah, they're all steel.
Mm-hmm. All right. Well, listen, Gilbert, awesome having you on the show today. Thank you so much for spending time.
You promised next time you're coming to Honduras. So when we have the big production facility, you come down here and we show it to you.
Hey, listen, not only show it, we'll live stream from Honduras and show the world what you're doing there. I think that would be awesome. I cannot wait for the world to open up so we can go visit people like yourself. I love it.
Okay.
All right. Well, listen, everybody, please check the comments and weigh in an effort to advance further adoption of offsite construction solutions. Our goal is to define the products, define the options available so the marketplace, the consumer, the buyer, developer, right, including government agencies and others, know what to ask for. So we are doing a poll today. We put it in the comments. Really would appreciate it if you go check out that poll. Let's all get together. Let's define who we are as an industry. Let's define our products and what the options are so the people out there that want your products, our products, my products, know exactly what to ask for and how to look for us, to include our own government. So with that said, once again, thank you to Forward Solutions Group and Howick for sponsoring today's show. Gilbert, it's been awesome talking to you and seeing your product.
Thank you. I had a lot of fun too.
Don't go anywhere. We'll talk right after the outro here. I'll come back to you. And everybody else out there, thank you so much. We will see you on Friday for BS Friday with Mark Bare Naked Willie. BS stands for Building Science. We talk about it every Friday. My name's Dave Cooper. Gilbert Meyer, CEO and founder of MMC-3. Love it. We'll see you next time. Bye, everybody.